Why is it useful to write a ratio of fractions as a unit rate? Think about this question during the lesson. This is Sergio. He's training for a triathlon. That's swimming, cycling, and running, all in the same race. His target speed for cycling is 25 miles per 1 hour. Did Sergio achieve his target speed for the first 7 miles of his ride? You can use a unit rate to describe Sergio's cycling speed. To start, use the distance Sergio traveled during the first part of his ride. Sergio traveled 7 miles in 15 minutes. Let's draw a diagram that shows the distance Sergio travels in relation to the time he bikes. His target speed is in hours, and the first part of his training ride is in minutes. How can you express his time in hours?
Select your answer.
Minutes is 15/60ths of an hour. So 15 minutes equals 1/4 of an hour, or a quarter hour. Assuming Sergio continues at the same speed, he travels the same distance every quarter of an hour. To show the distance traveled in 1 hour, repeat the diagram 4 times. Now, make a table of equivalent ratios to find the unit rate.
Alright, so we have miles and we have hours. What should I put in those first 2 boxes?
The top row is the distance traveled in miles, 7 miles. The bottom row is the time in hours, 1/4 of an hour. You can find the unit rate by multiplying each term by the same number. Finally, compare the 2 unit rates. If Sergio maintains his speed, will he achieve his target speed?
Select your answer.
In order to answer this question, we have to figure out what's the unit rate. We know we're trying to figure out if he went 25 miles in 1 hour, but we need to figure out what the actual unit rate was. What we did here, we know we multiply 1/4 by 4. And when we multiply 1/4 by 4, that gives us 1. So in 1 hour, we have to figure out how much he traveled, how many miles he traveled. Well, we have to multiply 7 times 4, which is 28. So we have to ask ourselves, well, he actually went 28 miles in 1 hour, and the goal was to go 25 miles in 1 hour, at least 25 miles in 1 hour.
His target speed is 25 miles per hour. At a rate of 7 miles every quarter of an hour, he'll travel 28 miles in 1 hour, or 28 miles per hour. His cycling speed is more than his target speed. Way to go, Sergio!
Sergio increases his target speed to 30 miles per hour. How many more miles does Sergio need to ride in 1/4 hour to achieve this target speed? How does the unit rate describe Sergio's cycling speed? How is the unit rate helpful in determining how much farther Sergio must cycle in a given amount of time each time he increases his target speed?
Bronwyn mows the lawn every other weekend. She can mow 12,000 square feet in 2/3 of an hour. The lawn is 36,000 square feet. How long does it take her to mow the entire lawn? First, find the unit rate at which Bronwyn mows the lawn. How many square feet does Bronwyn mow in 1 hour? To find the unit rate, multiply the numerator and denominator by 3/2. Simplify. Bronwyn mows at a rate of 18,000 square feet per hour. Next, find the time it takes Bronwyn to mow the entire lawn. What times 18,000 equals 36,000? 18,000 times 2 equals 36,000. Multiply each term of the unit rate by 2 for the area of the entire lawn. Now simplify. How do the operations used in the table relate to the operations used in the equations at the left? The operations used to complete the table were the same as the operations used to find the equivalent ratios. Both models can be used to solve the problem.
Every other weekend, Bronwyn's brother Daniel mows the lawn. He can mow 15,000 square feet in 3/4 of an hour. Who mows the lawn in less time? Explain.
We know it would take Bronwyn 2 hours to mow the entire lawn. Now we need to figure out how long it would take Daniel to mow the entire lawn. And we can set up our unit rate just like we did with Bronwyn. We are going to put feet in our numerator, feet squared, and we know that's 15,000 feet squared. And in our denominator, we are going to put hours. And the number that's associated with hours is 3/4. Now, we cannot divide with fractions. So we have to multiply the numerator and the denominator by the multiplicative inverse of the denominator, which is the reciprocal. So I'm going to change this 15,000 to a fraction, just put it over 1, and then I'm going to multiply numerator and denominator by the reciprocal. Now I need to cross simplify. I know in my denominator it will be 1 hour. Now if I cross simplify up here, this 3 becomes 1, and I know 3 goes into 15 5 times, and then you add your other 3 zeros. So I multiply across, so I have to multiply 5,000 times 4, and it will be 20,000, and that's feet squared. So Daniel can mow 20,000 feet in 1 hour. Remember with Bronwyn, he only mowed 18,000 feet squared in 1 hour. So to answer this question, who mows the lawn in less time? Well, Daniel, of course, because he mows more square feet per hour than Bronwyn.
Omar knows that his friend Chris lives 3/5 of a mile away. How far is the school from his house?
All right, so we are working with something we call a scale drawing, and we'll get more in depth with this in a different lesson. So we need to focus on Chris' house and Omar's house. Well, up here it says Omar knows that his friend Chris lives 3/5 miles away. But if we look on this scale drawing or this map, 3/5 miles is actually equal to 3/4 inches. 3/4 miles is equal to 3/4 inches. Now, in order to figure out the answer, we need to figure out how much 1 inch is equivalent to. So we can set up a unit rate. And if we're trying to get inches to 1, guess what? Inches will go in our denominator. And then we'll put miles in our numerator. So what number is associated with inches? Well, if we look here on our map, 3/4. And the number that's associated with miles, well, we look up here, it is 3/5. Now remember, you cannot divide a fraction by a fraction, so you have to multiply the numerator and denominator by the multiplicative inverse, or the reciprocal of the denominator, which is 4/3. Now I'm going to cross simplify my denominator. I know everything simplifies to 1, and I'm left with 1 inch in my denominator. Now I'm going to see if I can cross simplify my numerator. Well, I know 3 and 3 are both divisible by 3, and they equal 1. Now I cannot cross simplify 4 and 5, so now I'm just going to multiply straight across. Well, 1 times 4 is 4, and 5 times 1 is 5, and I'm left with miles. So this lets me know 1 inch is actually equivalent to 4/5 miles. Now the question is, how far is the school from the house? Well, we know on this scale drawing or this map, it is 2 inches away. It is 2 inches away. So what do we have to do to figure out how far it is in miles? Well, we found out the unit rate. 1 inch is actually equivalent to 4/5 miles. So we're trying to get inches to 2. Well, what did I do to 1 inch? What did I multiply 1 inch by to get to 2 inches? Well, I multiplied it by 2, and then you have to do the same thing to the numerator. Multiply that by 2. And I'll do that math over here. Multiply by 2 over 1, and now multiply straight across. So that will be 8/5. 8/5 miles. That is how far the school is from Omar's house. Or you can convert it to a mixed number. Well, 5 goes into 8 one time, and we have 3/5 left over. So 1 3/5 miles from Omar's house.
Sonoma bikes 5 miles to Paige's house. On a map, they measure that distance as 5/6 centimeter. The same map shows that the mall is 3.5 centimeters from Paige's house. What is the actual distance between Paige's house and the mall?
In order to help us figure out this problem, we can draw a map like it was in the example. Here is my map. Now you can draw your map any way you want to. Now I know from Sonoma's house to Paige's house, that is 5/6 centimeters. And from Paige's house to the mall, that's 3.5 centimeters. Now, in order to figure this out, we need to figure out how many miles is 1 centimeter. Now we can set this up. Remember, we're trying to get centimeters to 1, so we can do our unit rate. We are trying to get centimeters to 1, and then miles should be in our numerator. The number that goes along with centimeters is 5/6. Now we're going to use the distance from Sonoma's to Paige's house because we have that information along with the miles. Now we can't use 3.5 because we don't know how far that is in miles. That's what we're trying to find. So we're going to use 5/6 for the centimeters and 5 for the miles. Now we're going to make that 5 as a fraction and put it over 1. Now remember, you can't divide a fraction by a fraction, so you have to multiply the numerator and denominator by the multiplicative inverse of the denominator, which is 6/5. Now I'm going to simplify my denominator. And I know when I cross simplify, I am left with 1 centimeter. Now I'm going to see if I can cross simplify the numerator. And yes, I can. 5 and 5 are both divisible by 5. And 5 divided by 5 is 1. So when I multiply across, I am left with 6 miles. That lets me know 1 centimeter is equal to 6 miles. So now I am trying to get 1 centimeter to 3.5 centimeters. Well, what did I do to 1 centimeter to get it to 3.5? I had to multiply that by 3.5. Now remember, maintain equivalency, so whatever you do to the denominator, you have to do the same thing to the numerator. Now I'm going to do my math down here. 6 times 3.5. Now when you're multiplying rational numbers, they have to be in the same form. So I'm going to convert both of them to fractions. 6 as a fraction is 6/1, and 3.5 as an improper fraction is 7/2. Now I'm going to cross simplify. 6 and 2 are divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Now I'm going to multiply across. 3 times 7 is 21, and I know that would be over 1. So I'll insert my answer here. Now to answer that question, what is the actual distance between Paige's house and the mall? The actual distance between Paige's house and the mall is 21 miles.